Next, we are going to study about the die cutting operations or die shaping operation. Okay, if you use either a die set, I would say what is die set. Actually, the die set is consists of a punch and a die. Okay, it consists of a punch and a die, and this is the main two components in a die set: a punch plus a die. So, in a die set, using a die set, we can use two operations. The first one is the die cutting operation. Die cutting operation. Okay. So using die set, we can use cutting operation. For example, in that we already discussed this shearing operation. See this here. This is a die cutting operation. We cut a portion from the raw material as a blank. Okay. So this is the die cutting operation. Okay. So that is the first use of die set. That is first one is cutting. Second one, we can use the same die set with a different punch and die. Actually, the profile will be different. Can be used for shaping operation. For example, the shaping using punch is this is the example, that is deep drawing operation. Here we can see the same punch and die is used with a different profile, and using this die and punch or die set, we can shape the workpiece. Okay, we can shape the workpiece. See this. Okay, so here we can see we shape the blank. We shape the blank. This is the rounded blank we kept here. Rounded blank we kept here. Then after shaping, we got a cut shapen number. Okay, so this is the punch. This is the die. Okay. So using this die punch set or die set, we can do either this cutting operation or shaping operation. So what are the main components in a die set? The main component is first one is punch in a die in a set, and that is actually kept in a punch holder, and a die. Second one is the die, which is actually originally fixed in a die shoe. Okay, that is the main two components. And third component is stripper. Stripper. In this figure, we can see the stripper. This one is the stripper. Okay. So what is the use of stripper? For example, if you're doing a blanking operation. So when the punch is posed in this downward direction, the punch make a cut on this workpiece. This is the workpiece, and the punch make a cut on the workpiece. 1 second. So the punch make a cut on this workpiece, and the punch moving downward. The punch is moving downward. So when it moving downward, there is a chance for the sticking of the blank with the punch. Okay, ഈ പഞ്ചിന്റെ ഈ ബോട്ടം സൈഡിൽ ഈ ബ്ലാങ്ക് അതായത് ഈ കട്ട് പീസ് സ്റ്റിക്ക് ചെയ്തിരിക്കും. സോ വെൻ വി മൂവ് ദ പ്ലഞ്ച് അപ്വേർഡ് ഓർ റീഡയറക്റ്റ് മോഷനിൽ അല്ലെങ്കിൽ റിലീസ് ചെയ്യുന്ന മോഷനിൽ the blank also may move upward. Okay, so to remove the blank, we use this stripper plate. Okay, that is the use of stripper plate. So stripper plate is used to discard the workpiece outside the press after the completion of the cutting or forming operation. After the cutting, when the punch follows upward stroke, the blank is stripped off from the punch cutting edge and prevent it from being lifted along with the punch. So when the punch moving upward, during the upward stroke of the punch, there is a chance for the upward movement of the blank along with the punch. To avoid this upward movement and to strip off this blank, we use this stripper plate. That is the use of stripper plate. Then we have a punch holder. It is known, another name is called upper shoe of the die set. Punch holder is clamped to the ram of the press. Here we can see this is the ram. Okay, and in this ram we use a punch holder. This one is the punch holder. Okay, in this punch holder we place the punch. This one is the punch. Okay, so to hold the punch we use punch holder, or another name is upper shoe or upper side. Then punch, that is the main tool, either in cutting operation or in forming operation. We need a punch, that is actually applying a force on the workpiece against the die. Okay. Then next one is die holder, which is again another name is called a die shoe, and which is support the block and rigidly boister plate of the press. So we can see this is the bed of the press. This is the boister plate. Okay, supporting plate, and in that we kept the die block. This one is the die block. Okay, this one is the die block. In this die block, we have a simple image in the. So this is the die plate, and this is the die set and the die set, and here this is the die inside. According to the shape or size of the blank record, we can insert this die inside. Okay, അപ്പോൾ നമുക്ക് ഇതിങ്ങനെ വേരി ചെയ്യാം. ഓരോ ഡൈ പ്ലേറ്റിൽ അല്ലെങ്കിൽ ഡൈ ബ്ലോക്കിൽ നമുക്ക് ഡൈ സെറ്റ് റീപ്ലേസ് ചെയ്യാൻ പറ്റും. Then here we can see the stripper plate, then stripper insert. Actually, that is all the material, and this is the punch moving downward. Okay, so these are the main components in the die set. This is called die set. We can use the die set for cutting operation as well as for forming or shaping operation. So we can see the die set operation. Here this is the die set. Here in this we can see bottom, that is the bottom shoe or the die area, and the upper portion that is called the punch area, punch holder, ram, punch, etc. we can see in the upper area. Okay, so when we do a cutting operation here, see this is a strip or workpiece. So the ram moving downward. So when it is moving downward, so this is the punch, this one is the punch. Okay, this one is the punch, then it's moving downward and they produce a blank. And this is the stripper plate. This one is a stripper plate. Okay, actually the stripper plate, we can see the punch is here inside. Inside area, this is the punch. This one is the punch. Actually, the stripper plate actually prevent the motion of the blank in the upward direction when punch is moving upward. Okay, and we can produce blank here. And this is this color one. This golden color one is the die. This is the ram. Okay, so these are the main components of the die set. Next, the classification of dies. There are different types of dies can be used for cutting and shaping operation. Basically, the dies are classified into two. I already explained what are the uses of die set. The first one is cutting dies. Second one is forming dies. Okay, so this is the example for the previous video. This one is the example for cutting die. Here we can see one portion or one blank is cut from the workpiece. Okay, so here a cutting operation is takes place here. So we can say that is a cutting die. And second one, in the last video, a cup shaped product is made by shaping. So where we use shaping dies. So that is the initial classification, cutting die and a forming die. Next one is, again we can classify the dies into a compound die and a progressive die. One more is that a inverted die. Okay, compound die, progressive die, and one more, that is inverted die. So that is based on the number of operations performed in a stroke. Okay, but based on that we can classify into compound die and a progressive die. And this video actually, or okay, basically this is a three classification: multi operation, compound die and a progressive die. Single operation, we can say single operation die, simple die. So simple die, in a simple die we can do single operation. In a multi operation die we can do compound dies and a progressive die. Okay, for that we can use this compound die and a progressive die. So this is the main classification of die. So first we will discuss about the inverted die. So what is the main difference of inverted die and this simple die? This one is a simple die. This one is a simple die. So here we can see the blank is actually, after the cutting, the blank is actually moving in the downward direction. Okay, so the punch is moving in the downward direction during the cutting operation, and after cutting, the blank is also moving in the downward direction. This is the case of a simple die. Okay, simple die. Here also this is a one cutting operation. It's not a multiple cutting operation. In a simple die, this will be a one cutting operation. Okay, and in case of an inverted die, the direction is reversed. The entire direction is reversed in the inverted die. In case of inverted die, actually the punch is moving in the upward direction during the cutting stroke. Okay, punch is moving upward, and the blank is actually after the cutting is also moving in the upward direction. That is called a inverted die. So that is the symbol die with a reverse direction. We can say that is a inverted die. Okay. So this is punch is mounted on the ram and is given a vertical movement while the die is stationary and attached to the die shoe. The arrangement of the entire arrangement is reversed in the inverter die. That is the main difference between the simple die and the inverter die. Okay. So here, what is the advantage of by this reversing the direction? We can do a thin blank bending. Thin sheets can be cut without any bending. Okay. So that is the main advantage of the this inverter die. We can see the figure of the inverter die. See this here, the punch is actually moving in this upward direction. Okay, during the cutting stroke, and see this the blank is actually made here. Okay, this is the blank. So the motion is in the upward direction. That is only difference between the simple die and the inverter die. So it can be used for the main advantage of inverter die is that there is a little chance for thin blank being bent. So during the cutting operation, without bending, we can cut very thin sheets. That is the main advantage of inverter die. But the construction cost compared to simple die is high in case of inverter die. Second one is the progressive die. Progressive die. So actually, this cutting operation or the die shaping or die cutting operation is actually a time consuming and a cost consuming process because it's a very heavy machinery, and to improve the productivity, instead of a single cut, here we can see during the punch movement, here we have only single cut, right? A single blank is only produced here. Okay, this is a single operation die. But if we can do multiple operation in a single stroke of the die, then we can improve the productivity. Okay, for that we use two dies called a progressive die and a compound die. Okay, progressive die and a compound die. And next we will see the video what is progressive die. So we can make this product. See this product. See this product. We can make this product in a single stroke using a progressive die. Actually, in this product, actually I have a rectangular workpiece. We can see the rectangular workpiece here. Okay, and to make this product, what we do? Initially, I make two holes. Okay, I make two holes using a set of punch. Here we can see here there are one. This is the first punch, second punch, the blue color one, third punch, fourth punch. Here we have four punch. Okay, so during the downward motion of the ram, actually the four punches are actually apply a force against the workpiece. Okay, so we can see during the during the downward stroke of the ram, this punch number 1 and 2 make these two hole on the workpiece. Okay, okay, then the workpiece move forward, and this area, these two area come under the punch 3, comes under the punch 3, and the punch 3 what they do, so it move forward, these two holes move forward. So the next position of the hole is here, which is under the punch 3, which is under punch 3. Okay, this punch 3 cut the workpiece like this, cut the workpiece like this, punch 3. Okay, and we got this product. And punch 4 actually making a rectangle here. So we can see the video here. See this. So in a single stroke, how many cuttings are there? There are 4 cutting. Okay, but in case of simple die, in a one stroke there is only 1 cutting, but here we have 4 cutting. So that is the main difference between the simple die and the progressive die. Here we can see the cutting. So this is a section view. Here we can see during the downward stroke, see this die number 1 and 2 make these two hole. See these two hole. Here we have a hole. Here also we have a hole. Okay. So in the next stage, after the production of this hole, the workpiece move forward. Okay. And next stroke, in the next stroke, this die number 3 make a cut like this around the hole. Okay, see this, see carefully. See this, see this. Here we can see here we have two hole. Then around the two hole, another cut is made by the punch 3. Okay, so actually here we have a single stroke, but in a single stroke we make a product with the 1, 2, 3 cuttings. 3 cuttings. Okay, so this is called progressive die. Okay, so 2 or more operations at a time at a different location. This is also important. It's not in a single location. Here we can see the 2 or more operations is not in a single location. The 2 holes are produced here in this location, but around the holes a cutting is made in this location. So actually the operations performed in a single stroke, but the operation will be in the different locations of the workpiece. Okay, so that is the main characteristics of the progressive die. So at a different location of the stroke strip. Okay, so different operations are carried out one after the other as the place advance through the progressive die. Okay, that is the progressive die. Here, for example, this is another example. How can we make a washer? This is a washer. A washer. How can we make a washer with a progressive die? A plate. Actually, a plate is coming in this direction. So here we have a piercing punch. Okay, this piercing punch make a hole here. Okay, a hole is produced by piercing punch. Then the workpiece move forward in this direction towards the left, and in the next stroke, the workpiece location will be here with a hole, workpiece with a hole. When the blanking punch move forward or moving downward, a blanking punch produce this type of cut. And finally we got a washer with a center hole. Okay, so in the first stroke, what we do? We do a punching using or piercing, and we produce a hole. Then the workpiece move in this direction. Here we cut a blank. So we got a blank with the center hole. That is the washer. Okay, so this is the progressive die operation. So what is the advantage? Using the progressive die in a single stroke, we can do number of operations so that we can increase the productivity. That is the main advantage of using progressive die compared to single die. So next one is compound die. It is almost similar to the progressive die, but the main difference is that in the case of compound die, we do the multiple operation in a same location. Okay, so but in case of this progressive die, we can see here the hole is produced in this location, then the blank cut is produced here in this location. At a different location, we are doing multiple operations. Okay, not in a single location of the workpiece. But here in the compound die, we perform all the operation in a single location. That is the main at the same station or single location. Okay, we do the entire operations. That is the main characteristics of the compound die. We can see the compound die here, the operations of the compound die. Actually, here also I want to make a washer. Okay, a washer with a center hole. Okay, a center hole washer I am going to make using a compound die. So actually here we can see. So this is the actually I will show a See this. This is the top view. This one is the top view. Okay. This one is the top view of the workpiece. Okay. So let's see how can we make this type of washer. This type of washer. Okay. So here the workpiece is actually moving in this direction. Workpiece is moving in this direction. Okay. During each drop, it is moving forward. So here,
beneficial to show a top view of the
see this. നിങ്ങൾ കുറച്ച് ശ്രദ്ധിച്ചിരുന്നാലേ ഇത് മനസ്സിലാവുള്ളൂ. So first stroke, see the first stroke.
operation much better. It would be beneficial.
See this. First we can see the pink color. This pink color dye and this orange color dye. This is also a punch and dye. This is a punch and dye. Okay. These two are the punch and dye. This is cutting a blank from the workpiece. Actually the workpiece is like this. It is like this. And using this pink color dye and this orange color dye, a blank is produced like this. That means from the workpiece, a blank like this is produced. We got a blank like this. Okay. This is the operation. We can see again. See this. See carefully. So this black color one means a complete workpiece. And when it is come under,
To understand the cutting operation
downward motion, see this downward
much
motion.
better. It would be
See
beneficial.
this. Initially a cut is made and a blank similar to this shape is produced. Okay. A cut is not using this punch. The punch is not cut the workpiece. This punch is not cut the workpiece, but the pink color and this orange color dye and punch make this cut. Okay. And we produce a circular blank.
To show it.
Then after that, the punch moving downward and punch make a cut on the same location. Punch make a hole on the blank. We can see a hole is made on the blank. See this. Okay, a hole is made on the blank. So in the same location, we do blank cutting. At the same time, a hole is also made on the blank. Again, we can see.
Should be added on the stripper to prevent catastrophic failures.
First blank cutting, then hole cutting.
To understand the cutting operation much better, it would be beneficial to show a top view of the metal strip.
Blank cutting, then hole cutting.
As you can see, when the strip advances to the cutting position, the washer is cut with a single stroke and placed in the groove where it was before the cut and carried away with the strip.
See this, the washer is coming out.
Compound dies are usually used for
compound die. We perform the operation in a single location. We do multiple operation, but multiple operation is performed in a same location. That is the difference between progressive die and a compound die. Okay. So this is the progressive die. Here using these two dies, blanking die. This one is the blanking die, and this is the blanking punch. This one is the blanking punch. Using that, we make a circular blank. Then this is the piercing punch. When it after producing a blank, this piercing punch moving downward and which produce a hole on the product, and we can make this washer. Any doubt in this? ആർക്കെങ്കിലും മനസ്സിലാവാത്തുണ്ടോ?
Welcome to the video tutorial.
ആർക്കെങ്കിലും മനസ്സിലാവാത്തുണ്ടോ? മനസ്സിലായോ? Difference between progressive and compound die. Okay, അല്ലേ? മനസ്സിലായില്ലേ? Hello?
Yes, sir. മനസ്സിലായി.
Yes, sir. മനസ്സിലായി.
Okay, fine. So that is about the cutting operations we can perform using die set. Okay. So this is the last portion of the module 5. Different cutting dies and classification dies, progressive die and compound die. Okay. Next we have a portion from the 4th module, the last portion in the 4th module, that is actually the deep drawing operation. Deep drawing operation. We already discussed about the drawing operation. What is a drawing operation? In case of a drawing operation, we have a very small opening die, and through the die we pull the workpiece and make a very small thickness or diameter wire shaped components. Okay, and any cross section components can be made using drawing operation. Actually, where we apply a pulling force. Here we apply pulling force to the workpiece to convert the raw material to final product. That is the drawing operation. Next, we are going to study about deep drawing operation. Deep drawing operation. Here in this case of deep drawing also, this is a shaping operation. Here we studied the cutting operations. Okay, but using the die and punch, we can shape the workpiece into a particular shape. Okay, or we can form the workpiece into a particular shape. We can see varieties of product made by deep drawing operation. So we can see in this in most of the products we can see compared to the diameter. See the diameter compared to the diameter, the height of the product is very high. Okay, height of the product is very high. That is why we call this as a deep drawing. Deep drawing. Okay, the height or depth of the product is comparatively higher, very higher than that of the diameter of the product. Okay, so we can make this type of products using deep drawing operation. So what is a deep drawing? How we do the deep drawing operation? For the deep drawing also we can use the die set, that is the punch and die, and here we have a blank, a circular blank or a rectangular blank based on the application or product requirement. We make first we have a blank. Okay, we can make the blank from the shearing operation. So using this blank, what we do, we make a cup shaped products. A cup shaped products can be made using this blank. Okay, so it may be the cross section may be a circular shape, or it may be a box shaped products also. We can make the box shaped products also. Okay, this is the top view. This is the top view of the circular shaped cup shaped product. This is the box shaped product. Okay, but here the depth is very higher compared to the diameter of the product. That is the main characteristics of the deep drawing component. Okay, in some case we make shallow parts. In case of shallow parts, here we can see shallow parts. See this here. If you take this one, the depth is not much higher compared to the diameter. So that type of parts are called shallow parts. But if the depth here we can see this here the depth is very large compared to the diameter. Okay, so this product can be say this is a deep drawn part, and this product we can say shallow part. But commonly we call this as a deep drawing parts. Okay, we can make different products. Main example is the the beverage cans, Coca-Cola can. So this type of products we can make using deep drawing operation. So the round sheet blank is placed over the circular die. We have a circular die, okay, and in this circular die, we have a circular die like this, and we place a round shaped. This is the front view. A round shaped blank is kept over the circular die, okay, and we have a blank holder here. This is the blank holder to keep the workpiece in rigidly during the punching operation. We use a blank holder, okay, and we have a punch. This is the punch. This is the punch, and we force the punch against this workpiece. This is the workpiece against the workpiece. Okay, so what happened when we force the punch against the workpiece starts to bend and form a cup shaped product. Cup shaped product is produced. Okay, after bending, we got this type of cup shaped product. Okay, so this process is called the deep drawing process. We can see actually this is a half sectional view of the deep drawing process. So this one we will discuss different components, and this is the punch. This is the die. Okay, and this is the blank. The circular blank is kept over the die, and this okay, this is the blank holder. Okay, so we can see when the punch moving downward. See this product after deep drawing operation. Actually, we discussed about the inverted cutting and simple cutting and inverted cutting. So that is cutting operation, but here we can see here in this blank is produced in the final product. The punch is moving in the downward direction, but here okay. Actually, this is a sectional view. The complete under a cup shaped product is the output. So this is the deep drawing operation. So we can see a deep drawing operation here. This is also an inverted type. Video kanda second type aanu ee kanunna. Here this is the punch. The punch is actually moving in this direction, and this is the die area. Okay. This is the blank kept over the die. Blind holder. Okay. We originally fix the using workpiece using blind holder. Then see this, the punch is moving upward. Punch is moving upward, or the entire die set is moving downward. Both operations are same. And this one is the die. This is the deep drawing operation. Okay, so here actually the left side view is blank before forming operation or deep drawing. So we kept the blank here. This is the blank holder, and we force the punch against the blank. Okay, so when we force, what happened? So this is the blank we kept. Okay, this is actually one side view, left side view. Okay, left side view, left section view. Okay, so after punching or after deep drawing operation, we can see the blank is actually bent and form a cup shaped product. See this, a bent product, a cup shaped product is produced. Okay, and this one is the blank holder, this is the die, and this is the stripper ring to avoid the upward movement. Okay, this is the pressure plate to force the workpiece in this die area or die blank holder area. Okay, so we can make this type of cup shaped products using deep drawing operation. And different variables parameters, this RP, that is the punch radius, RD, that is the die corner radius, and T is the thickness of the blank, and DP is the punch diameter, D0, that is the blank diameter, F is the force, and blank holding force. We should apply a particular force in the downward direction to hold the workpiece tightly, and this one is a die. Okay, these are the different parameters in the deep drawing operation. So see this, this is the workpiece, this one is the workpiece, and when we apply force, the workpiece is bent and form a cup shaped product. This is the cup shaped product. Okay, so this is die, this one is die, this is the punch. You can see here, the using blank holding force, we actually tied the two edges of the workpiece. So finally, these two edges of the blank is formed as a planche. Okay, planche, and we force the punch against the workpiece, and the workpiece is bent and form a cup shaped product. And so here, this is the different stages of operation. Here, first, this is we kept the blank here. kept the blank here, we force the punch, and here we apply some amount of blank holder force to hold the workpiece tightly. Then when we apply the force, initially we can see a bend. We can see a bend on the workpiece. Okay, we can see a bend. And after bending, actually this area, the flange area of the blank is actually rigidly fixed on by applying the blank holder force. Okay, so when we move the punch in the downward direction, after initial bend, next we will see a straightening. Okay, straightening. So we can see the material move from outside to the inner diameter area. In this direction, the material starts to flow. Okay, during this downward motion of the punch. And here we can see the workpiece is moving downward, and we can see a compression and a thickening of the flange. During the downward motion, we can see some amount of thickening on the flange, and finally we got, when we release the load, finally we got this type of cup shaped product. Or if we are not release the load, blank holding load, we got a clamp shape cup with a flange. So that is explained here. So at the beginning, as the punch begins to push the workpiece, it is bent over the corner of the punch. We can see the bending. Okay, over the corner of the punch and the die, it starts to bend. The outer edge of the blanks moves slightly towards the center at this stage. As the punch moves downward further, when punch moves further downward, the material also moves downward, and a straightening action takes place in the bent metal. We can see a straightening action we can see here. Okay. During this process, the flanges like to be wrinkled. There is a chance for wrinkling of the flanges. What is wrinkling? A wave-shaped profile may be produced on the flange. This is called wrinkling of the flange. Okay, wrinkling. This is not a perfectly flat, but a wave-shaped flange may produce during the second stage. So we should control the punching force and the blank holder force, etc., to avoid this wrinkling phenomena or wrinkling defect. So force applied, and but the force applied by the blank holder reduce or eliminate the wrinkling phenomena. By proper control of this force as a function of the punch travel, better result can be obtained. So we can avoid this wrinkling defect by proper control of the punching force and punch travel and this blank holding force also. Okay, by controlling these three parameters, we can control the wrinkling defect. Then after bending, so straightening, then next stage is straightening. Then after that, the more material come from the outside edge to the edge of the blank to the center region. Okay, so from the outside region of the blank, more material come to the center region during the downward motion of the workpiece or blank. Okay, and as the material in the outer periphery of the blank is drawn towards the center, is become thicker also. So what happened? This area become thicker. And the progressive downward motion of the punch result in a continuation of the metal flow due to drawing and compression. So we can see finally we have a compression, and there will be some amount of thinning in this region. Because of the punch force, there is a chance for thinning in the bottom of the cup region at the end stage. So this is called deep drawing, and here we can divide this is actually the wall surface of the cup product. This is the flange area, and this is actually the depth. Depth is provided in the cup wall. Okay, and this is the bottom area of the cup. Okay, so when we compare the different stresses developed in the three regions, we can see in the first region, that is in the flange region, actually we apply a punch force like this. Punch is actually kept here. So when we apply punch force in this downward direction, what happened? There will be three stresses developed in this region. What are the three stresses? First stresses is because of when the material move in this direction. Okay, from the flange area, material is moving in this direction, a tensile stress will be developed. This is a tensile stress on the flange area. Tensile stress. Okay. And here in this we can see a compressive force is applied on the blank. Okay, blank flange. A compressive force through the blank holder is applied on the flange area. So this compressive force is shown here. This is the compressive force applied on the flange area of the blank. Okay, and because of this compressive force, a hoop stress is developed in the opposite direction. Resisting hoop stress is developed, that is also a compressive in nature, is developed in the other face of the element in the flange area. So these are the three types of stresses developed in the flange area. Okay, so this is the compression produced by the blank holder, and this tensile force is developed because of the material movement in this radial direction, and the compressive force from the blank holder actually create a hoop stress in this direction, and this hoop stress is the main reason for the Bringling defect in the final product. Okay, so we should reduce the hoop stress in the final product. So that is about the stresses in the flange area. And if you take the cup wall, this is the cup wall. The cup wall area also we have different stresses. A longitudinal tensile stress will be developed by the contraction of the punch. Okay, so when the punch moving in this direction, in the downward direction, because of the contraction, actually a tensile stress is developed here. A tensile stress is developed on an element in the cup wall. But the width change since the punch oppose that. So here there will be a small change in the width since the punch oppose this longitudinal movement. Okay, so these are the two main stresses developed in the flange area. And the third stress developed in the punch bottom region, that is punch bottom region. Here the metal getting thinned down. That means by the punch force, here we have a punch. By the punch force, the material in the bottom region is thinned down, or the thickness is reduced in the bottom area. That is subjected to plane strain deformation, the bottom area. So these are the distribution stresses in the three regions of the redrawn component. The next one is drawability. Drawability means how much we can draw or deep draw a material or a blank. That is the drawability of the blank. Okay, for example, I take a blank with a particular diameter D0, and using a punch with the diameter DP, I convert this blank into a cup-shaped product. Okay, cup-shaped product. So how much I can deform, or how much I can shape the blank into a cup-shaped product, that actually explained using this term drawability. The ratio actually it is measured by the ratio of the initial blank diameter to the diameter of the cup drawn from the blank. Okay, the diameter of the cup drawn from the blank. And that is equal to the diameter of the punch, which is equal to the diameter of the punch. So, for example, for a material and a blank with a high drawability, then it can deep draw like this. Okay, it can deep draw like this to very small diameter dp. A d0 blank can be draw like this into very small diameter and very high depth. Okay, so we can say it has a very high drawability. For example, another case, another material and a blank with a limited drawability. The drawability is limited. Then I can only deform or make a cup-shaped product with a very lower thickness or very higher diameter. Okay, so it has a lower drawability. So this, how much I can deform into a cup-shaped product for a blank or material is explained using the term drawability. That is mainly based on the d0 by dp ratio. Okay, and this d0 by dp is called the limiting draw ratio. If the limiting draw ratio is very d0 by dp. So if the dp is very small, that means LDR, limiting draw ratio, is very higher, then we can say it has a very high drawability. If d0 by dp is very lower, then we can say drawability is low for that blank. Okay, then this is the equation for calculating a drawing force. How much amount of load has to supply through the punch for drawing, that is explained here. And here sigma y is the yield strength, and capital D is the diameter of the blank, small d is the diameter of the final product, T is the thickness, F is the drawing force. So this is the equations to calculate the drawing force required for cup drawing. Then there are different factors affecting the drawability. What is the die radius? What is the punch radius? What is the clearance between the punch and die? And how much amount of pressure is used to hold the workpiece? How much amount of lubrication is applied? So these are the different main factors which affect the drawability of the blank. Then defects, different defects are there. This is the Brinkley defect. I already explained. Some amount of hoop stress will be developed during the drawing process. This hoop stress develop a wavy flange on the final product. This is called a Brinkley defect. Then tearing. Tearing may be see. You can see the tearing. Actually, this is the Bringling on the flange. This is the Bringling on the cup-shaped product. Okay, both are Bringling. And this is the tearing on the corner portions. We can see this type of cracks develop. This is because of tearing. Okay, and this is mainly because high tensile stress causes thinning and failure of the material. So during the drawing operation, there is a chance for reducing the thickness. Here actually in ideal case we can say there is no such thickness reduction. But if we draw into very higher depth, in this area, the material becomes thin and finally leads to development of crack. That is the reason for this tearing. Okay. And another one is the earning defect. Earning defect is also a similar wavy defects in the surface of the or the edges of the workpiece. This is the earning defect. This is because of the anisotropy of the material. You know what is anisotropy, and because of the anisotropy, a wavy edges is formed on the edges of the final product. That is called a earning defect. Then some amount of surface scratches may be formed because of the rubbing on the surface. See these surface scratches. Okay, these are the main defects in the deep drawn compound. The last one is deep drawing practices. There are different important factors which are affecting the final product quality and the process parameters, etc. There are 8 components. The first one is mechanical property of the sheet metal. Mechanical property, it should have high formability or drawability. So the sigma y is an important factor. The second one is the radius and clearance. Okay, the die clearance and the die clearance means die radius. Die radius means this is the die radius or punch radius. This is the die radius. So these two are the important factors. Okay, and the clearance between the punch and die. Here we can see in this case we can see this much amount of clearance. And this clearance also an important factor which affect the final product quality. Okay, so if the die corner radius is very low, this type of cracks may be formed, tearings. If the punch corner radius is very low, this type of cracks may be formed. Okay, so this is a very important factor, clearance and radius. Then we use during the drawing operation, we use draw beds. Instead of blank holder, we use draw beds. Here we can see here to hold the workpiece tightly, we use a blank holder and we apply a compressive force in this downward direction. Okay, instead of using a blank holder, we can use a draw bed. This is the draw bed. Okay, so what is the draw bed? A small projection and a depression we can see here. A small projection here. So this is the draw bed. By providing a draw bed, we can improve the quality of the final product. Okay. And third one, blank holder pressure. That is also important one. Actually, how much amount of pressure is applied through the blank holder to fix the workpiece tightly against the die is the blank holder pressure. But actually during the operation we vary the blank holder pressure when we progress the drawing operation, and we are not keeping this blank holder pressure as a constant. We vary the blank holder pressure during the operation, okay, to make the very high quality final product. Then redrawing. Redrawing is another operation which is used to improve the formability or drawability of the material. Actually, in a simple conventional drawing process, what we do, we force the punch in the downward direction, okay, and we do the drawing operation. This is the drawing operation, okay. This is the conventional drawing operation, okay. Then after this drawing, then we do redrawing. So what is redrawing? In the redrawing, we kept the workpiece in the cup-shaped product in the reverse direction. We can see the workpiece is kept in the reverse direction. Again, we force the punch in the downward direction. So what happened? The material or the cup-shaped product is redrawn here. See this, a redrawing of the workpiece. This type of redrawing actually improve the drawability of the material, okay, and by this we can improve the ductility of the material because of the Boeshinger effect. You may study the Boeshinger effect. By this Boeshinger effect, we can improve the ductility and we can improve the formability of the material or drawability of the material. Then finally, we can do without using a punch holder. This type of die can be used. Okay, this type of die with a specific this profile is called a Tractrix profile, Tractrix die profile. So when we use this type of die, actually the material is bent like the shape of the die and actually moving in this direction. Okay, and we make a cup-shaped product. Here we are not using a blank holder for making this type of products. Okay, then we can use different tools and equipments for drawing operation. We use commonly tool steel as a material for making die and punch, and we use some alloyed cast iron for that to make the punch and die. Then we can use different mechanical hydraulic presses and a servo presses, etc. for the drawing operation, and we use different lubrications to increase the drawability, reduce the increase the tool life, reduce the punch force, etc. But there is a requirement of particular amount of friction. Minimum amount of friction is required to improve the drawability of the material. Okay, we should not reduce the friction beyond a limit. Okay, there is a requirement of friction to improve the drawability. So this is the different practices, important parameters which affect the material or deep drawing operation. Okay.